This video is on the objective find the linear regression equation given a list of data points. And I've actually shown you how to do this on the calculator in previous videos, if you've been watching in a previous assignment. I'm pretty much just going to be doing that again here, only with a different instruction. What we're doing here is we're looking at a scatter plot, right? A picture of points of data, and trying to figure out what line could I draw that would best fit that data, right? Get as close as possible to hitting all of them, with as little error as possible. All right, so let's take a look. All right. Actually, well, here's the problem. Right? And again, if you want to see more about the objective, click on More Instruction. I am going to read you some of that instruction right now. They have some videos, some notes, some examples. Hopefully all those help you out. So here's some of their instruction, some of their notes. So finding linear regression equations. So as you've seen with scatter plots, data rarely fit a straight line exactly. Right? The points that you plot don't always fit a straight line perfectly. Usually, you must be satisfied with rough predictions. Typically, you have a set of data whose scatter plot appears to fit a straight line. Notice they put fit in quotation marks there. So like this data down here, they're definitely not on a perfect straight line, but it does look like I could fit them with a line with a positive slope. They seem to be tending upward as I move to the right. So I'd say that this data here, have a positive linear relationship. So fitting them with a straight line, this is called a line of best fit, or least squares line, or least squares regression line, or the linear regression equation, right? Lots of names for the same thing. Line of best fit, least squares line, least squares regression line, linear regression equation, all mean the same thing. So they go over an example here. For example, let's say a random sample of 11 statistics students produced the following data, where X is their third exam score out of 80, and Y is their final exam score out of 200. And they have, and these are and each ordered pair is related to one student, right? So these are dependent lists. You can't just shuffle them up. 65 has to go with 175, 67 has to go with 133. And then each of these pairs of data corresponds to a pair like you would plot in an algebra class. You have your x-axis, or third exam scores, on the horizontal axis. Your y-axis, or the final exam scores, on the vertical axis. And then plot these, 11 points, which they have here. So the table and the scatter plot both show the scores on the students' final exams based on scores from their third exams. So they'd say that the third exam score X is the independent variable, and the final exam score Y is the dependent variable. Linear regression, right, finding this best fitting line, can help you predict the final exam score of a random student if you know that student's third exam score. If everyone were to try and fit a best fit line just by eye, all the lines would be drawn differently, right? If you were like, hey, look at this data and try to throw a line in here that best fits it. Well, some people might just pick 2 points and draw a line through them. Other people might draw a line that goes through the what looks like the middle and trends in the direction that all the data is, up and to the right. But we want we want to set up, criteria so that everyone gets the same best fit line. So we can calculate what is called a least squares regression line to obtain the best fit line. Right? So that's what this process is here. And this is what the calculator does, right, when it finds the best fit line for you. So the process of fitting the best fit line is called linear regression. The idea behind finding the best fit line is based on the assumption that the data are scattered about a straight line. The criteria for the best fit line is that the sum of the squared errors, SSE, sum of the squared errors, is minimized, thus the name least squares. Right? Sum of the squared errors is smallest, right, is minimized, where the distance between the points and the line are the smallest possible. Alright, so this best fit line is called the least squares regression line. Again, line of best fit, regression equation, all that stuff. So look at this diagram, right? So, here's a bunch of data. This is the data from up here, I believe. And, they say, hey, imagine there's a line running through them. That's the best one. And then what you do is you take every point which has a coordinate, say x0, y0. This is an actual point of data that they're pointing to here. And you calculate its, its vertical distance to this line. And the value on the line is called y0 hat. So y0 is the actual y value. And then y0 hat is the y coordinate on this line. Notice again, since I went straight up and down, they have the same x coordinate of x0. And then you take y0 minus y0 hat, the data, the actual value minus the line value, the predicted value. And their and then take the absolute value because we're just making, distance positive. And that's the absolute value of this epsilon 0, which, epsilon is a small little Greek e, and it's, for error. It's like the error. So you're just calculating all these errors and squaring them. Right, take every y0 minus y hat 0, and then you're going to square those eventually and add them up, and that's the sum of squared errors. But you do this for every single point data point. You calculate the distance between that data point and this line. So each point of data, right, is of the form xy, and each point on the line of best fit using least squares linear regression has the form x y hat. Right, again, y hat, and that's the estimated value of y, the predicted value of y. It's the value of y obtained using the regression line. And as I mentioned, the term y0 minus y hat 0, right, is the error, this epsilon 0, the error or residual. And the absolute value of a residual measures that vertical distance, right, between the actual data point and the line, the estimated value of y. So they kind of recap that here. In the diagram above, the point lies above the line, the point that they're pointing at, right, lies above the line, so that that y0 minus y hat sub 0 would be positive. The residual is positive. For each data point, you can calculate their residuals or errors by taking the difference between the actual point and the point directly above or below on the best fit line. In the example, there are 11 data points, so there are 11 of these distances. And then if you add these epsilon squared values, right, you take all the errors, all 11 of those differences, and square them and add them up. That's this sum of squared errors that was being talked about earlier, SSE. Now, we're not going to use calculus. No. but say using calculus, the values of A and B that make the SSE a minimum can be determined, which thus gives the points that are on the line of best fit. Now this equation looks like, again, y hat. Remember, this is the values on the line. So when you see y hat, you're talking about being on that line, not on the actual data points. Equals, I know in an earlier video it was ax plus b. Here it's a plus bx. Just remember that the number on the x is the slope, and the number without x is the y-intercept. Right. So you have a y-intercept plus and then some slope times x. The best fit line always passes through the point x bar, y bar, where x bar and y bar are the sample means. So x bar would be the average of all the x coordinates of the 11 points. Y bar would be the average of all the y coordinates of the 11 points. And the best fitting line always passes through this point, x bar comma y bar. The slope can be written as r times sy over sx, where sy is the standard deviation of the y values, those 11 y values up there. Sx is the standard deviation of the x values, and r is something called the correlation coefficient, which we'll get into in another objective. What is this r and what does it mean? All right, we'll talk about the correlation coefficient much more again in other videos. All right, so the line of best fit for the example given above is this blue line here, which has this equation. Slope is 4.83, right, the number attached to the x. The y-intercept is negative 173.51. Which doesn't really make a lot of sense looking at this, but yeah, but remember what slope tells us, right? Slope describes how changes in the variables are related, right? If I had a slope of 4.83, that means if I increase the third exam score by 1, the final exam score would go up by 4.83, on this blue line. So on average. It is important to interpret the slope of the line in the context of the situation represented by the data. So like I said, I just said what that meant. All right, so again, a lot of weird stuff going on here. You got SSE, we'll talk about that a lot more later, the sum of squared errors. This R, this correlation coefficient, we'll talk about that a lot more later. For right now in this section, you're just going to be using the calculator, which they get into here, and I'll be showing you. I've shown you in a previous video how to do this, and I'll show you again here how to find this best fit line, this regression equation for a table of data. All right, so let's actually get into it. So you got a lot of jargon there that will be discussed a lot more later. So here we're just simply finding the linear regression equation. All right. So using a calculator or statistical software, find the linear regression line for the data in the table below. And they want you to enter your answer in the form y equals, this is what you're probably used to, mx plus b, again, slope times x plus y-intercept, with m and b rounded to 2 decimal places. All right, so you have your x coordinates, you have your y coordinates. So I'll pull up the calculator. This is an 84 plus, right? 83, 84 are pretty similar. And we're going to make lists. Down one list, I'll put the x coordinates. Down another list, I'll put the y coordinates. Right, so you hit stat, enter on edit, and then I'll just do it down L1. I'll put these x coordinates 1 through 7. All right, And then down list L2 in the same order, I'll put the y coordinates. All right, so 4.59 and then 4.99. All right, and I'll come back when this is all done. All right, so you see now I've got all 7 x coordinates, all 7 corresponding y coordinates. Now first I want to show you a scatter plot. So I'll go second stat plot above the y equals button. Maybe go to plot 1. You've seen me do this before. Plot 1, turn it on. You know, it is a scatter plot. That's the first type there with the dots. X list is L1. The Y list, the Y coordinates are in L2. Then the graph, make sure that all the points actually get on my graph. I'm just going to hit the zoom button, and you can scroll down to number 9 or just hit number 9 for zoom stat, and it changes the window so all the points in your plots will show up. All your statistical graphs will show up on the screen. So here are these 7 points, and if you'd like to see what they are, right, you hit the trace button. There's 1, 4.59, 2, 4.99, 3, 6.74, and so on. All right, so get out of there, go back to the graph. Now again, it looks to me as though this data, they're rising as you move to the right. They're tending upwards. So I would say that these these variables x and y have a positive linear relationship. Because if I try to fit these with a good line, that line is going to have a positive slope. Right? It's going to tend upward. All right, so let's see what that best fit line is. All right, so let's get out of here. And then hit the stat button. Go over to calc. And then you see number 4. It says lin reg, and then ax plus b. So linear regression, that's what we're doing, finding this best fit line. And then what's your x list? L1. What's your y list? L2. Frequency list, I don't have a frequency list for any of these. Then if you want to store the regression equation as something, you can. So maybe I'll store it as a letter, like R for regression equation. So I'll hit like alpha and then R above the times. Oh, I guess you got to store it as a y variable. All right, forget that then. Never mind that. All right, so let's just x list L1, y list L2, no frequency list. Forget the storing for right now, and then calculate. And then look, see it's y equals ax plus b. So a is the number attached to x, that's the slope. B is not attached to x, that's the y-intercept. And they give you a and b here. Right? So, and they want us to round these to 2 decimal places, right? So y equals 1.07 if I rounded to 2 decimal places, 1.07x plus, and then b is 3.374, so 3.37 rounded to 2 decimal places. Now, if you want to graph this, right, go back to your y equals. Hit y equals. Now you see up here plot 1 is in black. That means the scatter plot's going to be graphed. And now you can enter the numbers I just did, 1.07, rounded x plus, and then 3.37 for the y-intercept. And look at the graph now. See that line is pretty close to hitting all those points. I mean, it's not gonna, right? Most of these scatter plots, they're not going to be perfectly straight lines. But that's, our best fit line. Okay. Now, if you want a little more accuracy, go back to y equals. Let me clear this. Those were rounded values, right? 1.07 and 3.37. If you want those unrounded values, the more accurate ones, and you want to graph your regression equation, this regression line, y1 equals, go to hit the variables button, vars, hit number 5 for statistics, and then move over twice to equations, EQ. You see the very first one is regression equation. Hit enter on that, and you see it's y equals, and then it put up that crazy crazy number, the numbers you saw with a and b when I did the linear. You see 3.374 for the y-intercept. There's your x, and then the number before that's the slope, 1.067, and then graph that. And you see, I mean, it looks basically the same because, again, all we did was round those to 2 decimal places. But you got your regression equation coming up here and, you know, doing a best fit of the points on the scatter plot. Okay. All right, but that's all we were asked for, right? It's just the slope and the y-intercept of the regression equation, the line of best fit rounded to 2 decimal places. Great. All right, and I believe that will be all for that. Yes. Okay. So hopefully watching me go over this, you know, looking at the more instruction, reading the answer explanations when they come up. You know, I'm hoping all this stuff helps you out when you go over this material on your own. And thank you very much for watching.